Hi, everyone. So I realized that we didn't get a chance to talk about something in the meeting, so I thought that I would explain it in a quick video for you guys. And it's just how to interpret output like the one that Excel provides you in relation to the formulas that are discussed in your textbook and in the slides. So this is the table that I got as output for what we did in class. And so we have each of our regions, North, South, Midwest, and East. We have our counts or in our sample size for each group. We have the mean for each group and the standard deviation. And then these are kind of our descriptive statistics, right, for each group. And then this table is our ANOVA analysis. So everything that we need to know about the ANOVA analysis. The first thing that it gives us is our source of variation. So in your textbook, it talks about comparing the variance between groups to the variance within groups. And sometimes this variance within groups is labeled as error. So we can think of within group variance and between group variance. And so in your textbook, it has formulas to calculate sum of squares. We're not going to focus on those formulas right now, but that's what this SS is giving you, the sum of squares that Excel has calculated for you for between groups and within groups. But what I did want to talk about is some of these other columns, this DF, this MSF column. Okay, so we have our sum of squares. We have a sum of squares between groups, within groups, and then we also have a total, which would just be these two added together. So if we added these two together, we would get our total. The same for our degrees of freedom. We have between groups, within groups. If we add 96 and 3, we get 99. So that's where these totals are coming from. But let's say that you weren't given these numbers. These numbers are really easy to calculate given the formulas that you have in your textbook, and it's all based on sample sizes. And so the first thing we can think about in terms of sample size is our total number of participants in the whole sample. So here we have the counts for each group. If we add all of these together, we would get our total number of participants. And we've worked with this data enough to know that we have a total number of participants of 100. We can also think about, here we could get the number of participants in each group, right? And we can also think about the number of groups that we have. And so in your book, it labels a number of groups as K. And so we have North, South, Midwest, and East. So we have 4 different groups. So to get our between groups degrees of freedom, that formula, if you look up between groups, degrees of freedom, that formula is K, right, minus 1. And so we get 3. And then our within groups, degrees of freedom, that formula is N minus K. So our total number of participants, 100, minus our total number of groups, which is 4. 100 minus 4 gives us 96. And so I know that we haven't talked about degrees of freedom very much. It's all based on our sample sizes, right? How many participants we have. But if you notice, it's kind of a corrected number. So what it's saying is that we shouldn't really think about 100 participants. Instead, we're really thinking about degrees of freedom 96. It's more like a correction for the fact that these formulas are complex and we have to take into account that we're working with estimates. And so it's making these corrections to say, hey, we're working with estimates, and actually we're using estimates to calculate other numbers. And so we really need to be conservative. And so by using degrees of freedom in our formulas instead of sample sizes, that's all it's doing. It's applying a correction to give us a more kind of conservative or cautious answer for our final answer. And so we're using these degrees of freedom to get other values. So let's say that we don't have this value or this one. We can actually easily calculate our mean square between groups and our mean square within groups here in Excel. And we have the formulas for these. So our between groups mean square, that's what the MS stands for. That would be our sum of squares between groups divided by our degrees of freedom between groups. And the same way for our within groups mean square, that would be our sum of squares within groups divided by our degrees of freedom within groups. And so all I would have to do is take my sum of squares between groups divided by my degrees of freedom between groups, and I get my mean square. And the same thing here. You take my sum of squares within groups divided by my degrees of freedom within groups, and I get that. Okay. So then to get our final F value. So in your textbook, it gives you a formula for F, and it says that F equals your between groups mean square divided by the within groups mean square. Okay, so if you didn't have your F here, you could use this formula, and all you would say is, okay, once I have my mean square, I know that it's the mean square for between groups divided by the mean square within groups. And then I get my F value. Right? So if you have, like you have for some of the homework questions and maybe a quiz question or two, I can't remember for the quiz. If you have an incomplete table, right, you know how to fill in values from this by using the formulas in your textbook and the information given. As long as you have your sum of squares and you know something about the number of groups and the total sample size, you can use your formulas to fill in missing values from the table. But let me know if you have any questions about this. All right, thanks guys.